Okay, guys, we will get started now. I'd like to welcome everybody to the Introduction to Blockchain webinar with CUNY SPS. My name is Jamil Sheikh. I am a professor at CUNY SPS in the Data Science Division, which is run by Arthur O'Connor and Roxana Ali. I'd like to thank them for giving me the opportunity to do this webinar, and I look forward to presenting to you guys, to the community, an introduction to blockchain. So I'm going to get started by first talking a little bit about myself and my background. Let's see here. So my background is in executive management. I run 3 companies right now. The first company that I run is called Override Labs, which we do blockchain advisory, including tokenomics and initial coin offerings, or ICOs, that you may have heard of. We also do blockchain education under an organization called Chain House. And I also run and operate Blockchain Federated, which is a marketing division or a marketing group that focuses on helping blockchain companies get out their products and services to grassroots communities across the US. I've been involved in technology for 20 years across different verticals and across different disciplines. And I currently am teaching data science at CUNY SPS and performance management at NYU. If you'd like to stay in touch with me, my LinkedIn link is right there. Please feel free to add me and shoot me a message. A little bit about the course that I teach at CUNY SPS. It's Data 602. In this course, you can learn advanced Python, and we use Python in the context of creating cryptocurrency trading applications. No knowledge is required in terms of Python or trading. You can learn that in the course. And then we also apply data analytics and machine learning algorithms to different blockchains like Bitcoin or Ethereum. And that's kind of the course that I've created this past semester. I will be revising the course and creating a newer version of it this coming fall. So if you are looking to get into the data science space, this is a course that you may wish to take, and you will gain a ton of exposure to blockchain and cryptocurrencies. So for this presentation, I do suggest that if you have any questions, please feel free to ask them towards the end. I'm going to allocate about 10 minutes of the presentation towards the end. This presentation is going to be interactive. I'm going to ask the audience some questions, and I do expect some responses. But then I expect hopefully you guys will have the questions, and you can have that towards the end of the talk. So let's get started. Now this talk is about blockchain and an introduction to blockchain, and the way that we can talk about what the blockchain is, I can basically in a very lazy manner paste up the definition of blockchain and put it up there, and everybody can see that a blockchain is a decentralized, distributed, immutable, and public digital ledger, and so on and so forth. There's a bunch of jargon that you'll see here. It's cryptography, consensus algorithms, and to a lot of people, this may be very, very clear what it means, but to a lot of other people, this may not be. So can we regard this talk over? Is this seminar over? Is this webinar over? The fact that I've kind of displayed the definition of blockchain, is that sufficient? So for most people, it's not. So what I want to do is take a very different approach, and the approach that I'm going to take, and your screens are turning dark on purpose, is that I want to take you into a different world. So I'm going to kind of play with your imagination a little bit, and imagine we're in a different reality, and you wake up one Sunday morning. It's a beautiful day, the birds are chirping, and you wake up, you have your robe on, you put your coffee into the coffee maker, and you're about to sit down to read the paper when you get a call from your friend, and they ask you, have you seen the news. And you're a little bit stunned and startled, and you say, no, I haven't, what's going on? And they hang up, and before they hang up, they say, turn on the TV. So you hastily go to the TV and turn it on, and there's the news blaring away, and this is what you see on the TV. So the world is waking up to this whole new reality that banks and all forms of money, all kinds of money, have completely and inexplicably disappeared. Like, there is no explanation as to why or how. This Sunday morning, everybody's waking up to this reality that there's this branch that was at this corner is no longer there. An ATM that was kind of in this brick wall, that ATM machine is no longer there. All forms of banking and money are kind of completely gone, right? With no explanation. So my question at this point to you guys, to the audience, is what now? Does anybody have any suggestion or ideas around what happens now? So I mean, we're a couple hours away from social chaos. Yes, in a week there's rioting. I would say less than a week, probably within a couple hours. We probably have a few hours before there's mass chaos and anarchy, and society basically falls apart. Now, that hasn't occurred right now in this story, right? So it's still Sunday. I'm still trying to figure out what's going on, and the rest of the world is trying to figure out what's going on. But I still need to eat my breakfast, right? So I still need to eat my breakfast, and so I jump in the elevator. I go down the building, and I go to the corner deli, and I've been going to this corner deli for 15 years, and there's a massive line in front of the deli. I walk in, and I say hello to the deli guy, and the deli guy says, "Hey, how you doing?" And I said, "Can you give me a bagel?" And his question to me then is like, "How are you going to pay for it?" Right? Um, so imagine you're the deli owner, like, and any one of you are the deli owner, and I'm standing in front of you. I need to purchase a bagel. I'm basically hungry. How would I go about obtaining that bagel from you? Does anybody have any suggestions on how I can obtain that bagel from you? We can barter. Excellent. That's a great idea. So in my apartment, I've got a sofa, one sofa, a large refrigerator, and that's all I've got. So, okay, so you got a promissory note. Excellent. Credit. Great. These are great ideas. The problem with barter is that it's an illiquid form of exchange, because in order for me to get that bagel, I need to have something what I consider and the other party considers is of equal value. If I bring down a refrigerator and drag it down, that's typically not going to give me an equal value exchange. So barter contains a liquidity issue. And so the idea of actually, and if we get some people saying promissory note, those are excellent ideas. So what I can do is I can issue what's called an IOU, which is an acronym for a promissory note. I basically write on a piece of paper that I promise to give you something down the road. Now, the challenge with the IOU is that since that's on a piece of paper, paper can be lost, and people can say, hey, I never really wrote that, or there can be some legibility issues about paper. So remember, in this time, in this story, everything is still working. Computers are still working. Email is still working. All these other forms of communication are working. Do you have any ideas around how I can communicate this IOU to the deli person? Let's say you're the deli person. How can I transmit this IOU to you in such a way that you can come back to me and say, well, actually, you did issue this IOU to me, right? Are there other mechanisms besides paper that I can give you this IOU? If you want to respond, you can respond maybe on the chat, or right. You can do it on the chat, or you can do it in the questions box. Right, some signature by both parties, email. Okay, so we've got two people with email, right? Email, some type of digital cryptography key, yes. email, online tracking of such records. Excellent. These are excellent answers. So the quickest way to do it is to use email. So I'll create an email and I go to, and this is an example of an email that I might create on that day, right? And I email it to my local deli guy, and I owe you, subject is I owe you. And I say, hey bro, this is crazy times, you know, whatever a bagel's worth, whenever I have a chance to pay it, I'm gonna pay it to you, right? So I send him this IOU. Now remember, there's a large line in front of the deli because everybody else is trying to get some food to eat and trying to figure out this new reality, right? What do you think? What do you think will be the inbox of the deli guy? What will the inbox of the deli guy look like as he starts to take more and more, or she starts to take more and more IOUs? It'll start to get full, right? So it's going to overflow with emails. It's going to become unmanageable. I myself have to now I've got my bagel. I'm now going to go to a coffee shop to pick up coffee. I'm going to go get my groceries, and I'm going to go get my dry cleaning. I'm looking to get a haircut. So my Sunday morning is going to be issuing IOUs via emails. All of these shop owners are going to have a ton of IOUs coming um, into their um, into their inboxes, and it's flooding their inboxes. So my inbox is going to start to look like this. I'm going to have a bunch of IOUs going out to the barber, to the grocery store, and so on and so forth, right? But these IOUs are being exchanged digitally, and they're piling up. Now, it allows society to function for a short period of time. I'm able to transact and get some goods and services, and the other side, they're able to get some promissory notes. They're able to know who issued this promissory note, meaning that they know that this came from my email address and not anybody else's email address. So they can say, yes, Jamil, you did issue this with some degree of confidence. Now, let's say I'm a journalist. It's still Sunday afternoon, and I have a deadline by Monday morning. My dirty secret is I actually outsource my writing. I have a deadline Monday morning to submit to a blog that I am famously writing for, and I get a ton of money to deliver content to, but I outsource it. I have a friend in Seattle. Her name is Sarah. She does the writing for me. I pay her a different amount of money, a lower amount of money, and she does the writing. I kind of copy and paste that into my email and send it to my boss, and I collect the big bucks. However, Sarah is a shrewd businesswoman, and what she requires is 50% down, right? She wants a payment for her writing services, but she wants 50% of it down. I'm in New York, she's in Seattle, right? And she's not going to take an IOU, right? So what do I do? What are my options at this point? Does anybody have any suggestions or ideas? How can I get her something of value within the next couple of hours across the country, such that she'd be comfortable writing the blog and then give it to me, and then I can pay her the balance 50%. How can I do that? So I have to find someone I know in Seattle who'll trade, but then they're gonna say, well, why should I do it on your behalf, Jamil? Like, so I find somebody, I find a proxy, and they're gonna trade, so I'm gonna have to enter an IOU with you, so I've got to find an intermediary, pair with Bitcoin. At this point, there is no such thing as Bitcoin. There's no form of currency. Any suggestions? So one of the things I can do is I could attach a PDF of a document that she might find valuable. Let's say I have a PDF of War and Peace, which is a very large piece of literature, and I attach it to a PDF and I send it to her, right? And do you think that form of compensation is something that she might be amenable to taking? Is that a sustainable form of compensation? What's wrong with me sending a PDF of a document that might have some initial value? What's wrong with that? It's not liquid. True, it's not yet. It has some liquidity issues, but imagine um, that I do send it. What happens to the value of the doc? Exactly, it can be shared further and further, right? So what happens to the value of the document or that PDF the more and more people have it of it. The more and more people have of it, right, the value goes down. It actually goes down and approaches zero, right? So I can't trade a digital asset because there's no way for me to fence or to put boundaries or to contain the value of that PDF. So where we are right now is actually around 2007, 2008. We're kind of in the mind of Satoshi Nakamoto, who was the creator of Bitcoin. And some of the problems that we're wrestling with, and we're going to be wrestling with some more of these problems in coming slides, are the challenges that he's trying to address or she's trying to address in figuring out how do I move value electronically in such a way that it's not repeatable or reproducible, right? So right now coming back to New York City today, I'm trying to transmit some value to Sarah. So what I try to do is say, hey, look, this is what I'm going to do, Sarah. I'm going to create this file. It's going to be called one.txt, which is an empty file that I create in Notepad. I just open up Notepad and I create a file and there's nothing in it and I save it and I call it one.txt and I send her an email and say, look, Sarah, I'm going to attach this file. I'm attaching to my email and just please take this as a form of compensation and just send me the blog post writing. Please send me the writing. Here's a file. It's a digital asset. What do you think her answer is going to be? Like, is she going to go for this? Right. She's going to say no. Right. She's going to say that's not going to work. And the reason? What's the reason? Worthless. Right. So the problems with this is that it has no value. The file has no value. Right. So if we break these down, if we break these down as to why this file has no value, we can break it down into two kind of core economic principles that drive it to not have a value. One is infinite production, and two is double spend. The fact that I can produce it infinitely, right, and the fact that I can take one and spend it repeatedly, right, are the drivers of what force it to have zero value. If I can limit this or alter these factors, then I might be able to create some value in that digital asset, right? So knowing this is what I try to do. I'm going to try to take an attempt at solving the infinite production problem. And what I'm going to say is, hey, look, Sarah, I'm going to take a snapshot of my file system before and after. I'm going to create this folder called wallet. I'm going to put that one.txt file in the wallet. And I'm going to take a screenshot and I'm going to attach the file to the email like I did before, except this time I'm going to also show you that I've deleted it, right? So I can show you that in fact I can't spend it again, right? I can't produce it again. And I'm going to attach it and prove to you in the attachment. I'm going to put the screenshots in the email to show you that I've deleted the one.txt. And I send her that email. And what do you think her response is going to be? What would be your response if I asked you to do 2 hours of work and I sent you a file like that? You can restore it, still has no value, right? So still no value, even though let's say I'm honest in deleting it. So the next thing that I do, and she doesn't go for it, you guys are right, she doesn't go for it. The next thing that I do is I'm going to ratchet up the security parameters around this. So what I do is say, hey, I still have these two problems, they're not 100% solved. So what I'll do is I'm going to have I'm going to CC everybody. So the fact that I'm going to send that one.txt file and I CC everybody in the world, right? Once I CC everybody in the world, nobody will ever take that one.txt from me again because they know that I've already transferred it out. Whether I've deleted it or not, they won't care. I'm telling everybody that, hey, I'm already using this, right? So what I do is I send this one.txt again, and I say that this is payment, and now I happen to CC everyone in the world. Just assume that I can make this public and everybody can get a copy of this email. And I put in a screenshot showing that this file is no longer with me, right? And everybody has proof, or they know that I actually don't, I've already spent this, right? So I can't spend that one.txt again, right? And what do you think her answer is going to be? Would you still go for this? Would you? Okay, her answer is no. Some people are like, okay, so some people are warming up to the idea, right? So some people are saying, hey, we might be able to do something with this. Any other answers? Who would go for this? So it turns out that she would not still go for it because there's still no value, right? The fact that I've transferred this file and I've proven that I can transfer it only once, right? The public knows that I can't reuse that file again. Doesn't mean anything for her, right? She can't use it. There's no economic value for her, right? So this is what I do. I again, and in this, we're going through the mind of Satoshi Nakamoto. We're going to see the parallels to these exercises that we're going through with Bitcoin and the blockchain. I come up with what's called a unique essay algorithm. And what I do is say, hey, look, I'm going to write an essay in this one.txt thing. I'm just going to write this unique essay that nobody's ever written before. And so I write this essay. It starts off with, it fills me up with that gooey sap, and I write it, and I spend 4 hours to write this. Now, if I spend 4 hours to write this essay, how many of these essays can I write theoretically in a day? If it takes me 4 hours to write one, how many unique essays can I write in one day? Right, so a maximum of 6 if I don't sleep. I can write a maximum of 6 per day. Now what I'm doing is I'm reducing the ability for me to produce an infinite amount. I've kind of solved it with this unique essay algorithm, right? Uh, Now I can have the other party say, hey, um, you need to send me something, and I need to make sure when you send it to me that the public sees it and it contains something really unique in it. And I've solved the double spend problem by saying, hey, I'm going to CC and send a copy of this to everybody. The fact that this transaction is going to go to everybody, right? So what do you think her answer is going to be? What will her answer be? Now I've put in a ton of work, right? I put in some work. I've made the file somewhat valuable. There's a unique essay. Now, would you be willing to take this essay for, you write for me for 2 hours, some blog on something that I need? Would you take this essay and the fact that I CC everybody? Right. Okay, so there's still some issues, but some people are saying, yeah, they might take it, she might go for this, right? And so, but we're kind of moving closer to this capability to have this kind of trade and become something of value. Now, she might not find this valuable. She still finds it, well, I don't really care. Yeah, I don't care, Jamil, about your essay writing skills or whatever you write. That's not relevant to me. I just need cold hard cash. That's your problem to figure out how to get it. Now, so I kind of like strike out with Sarah, and now it's coming to be lunchtime. I'm getting hungry, and the fact that I'm hungry, I'm back to the same problem, except this time I have a cousin named Joey. He owns a pizza store, and I send him this email. I say, hey Joey, I've got this digital currency called TXT coin. It's the next big thing, I promise you, right? Um, and send me a pie, or send me 2 pies of pizza and accept this as payment. And I kind of plead with him, kind of play on his guilt, kind of make him feel guilty. And he's not the brightest. He's not the brightest of people. He's my cousin. A little bit gullible. He's a little bit, he's kind of close to me. He feels sorry for me sometimes. And what do you think I need? There's one missing ingredient that I need for him to be able to accept this attachment. What do you think that one missing ingredient is? It's one missing piece that I've kind of solved the double spend issue. I've kind of solved the infinite production issue to some degree. What does he need? Close. Guarantee is close. Transferability. He needs to trust you. Excellent. Right. So he needs to be able to believe me. Right. Which is the root of every form of currency. Right. Is that he needs to be able to believe that what I'm saying to him, that this is the next big thing, and once he does do that, then he'll be willing to accept it. And since he's a little bit, he's family, what do you think Joey's gonna say, right? What is he gonna say? Come on, Joey, you could take this. It's, send me the pies. What is Joey gonna say? Okay, we got some tough people here. Okay, so Joey says yes. Joey says yes, right? Joey says yes, right? Joey in particular should say yes, right? Joey in particular does say yes. So I send him the TXT attachment email. He sends me and we've done a kind of a digital crypto, not really a crypto, but a digital trade. Now this is what happened May 2010, May 22nd. In 2010, a guy named Laszlo actually sent 10,000 Bitcoins to a Papa John's, right? And got 2 pies of pizza for that, right? So this is the first time the world of digital currency or a digital asset, some digital asset was traded for some real world asset, right? We can debate about why, the 10,000 Bitcoins and if that was the right decision to make it at that point. But this is the first transaction. You can actually see this transaction if you go to blockchain.info. What you see on the left here in blue is a wallet. This is the ID for that wallet, for that account. And there's a movement of 10,000 Bitcoins going to the right to this other account on the Bitcoin blockchain. And this is the blue kind of hash up on top is the transaction identifier. And you see 10,000 Bitcoins moving. And this is considered the first Bitcoin transaction that took a virtual asset and traded for a real world asset. And the only reason such a transaction could have occurred is because all of the challenges that we were trying to deal with kind of in a sloppy way or haphazard way with our unique essay algorithm and all those specific problems were addressed, and the only missing ingredient was at this point was somebody believing in it, and then somebody actually did end up believing in it. Now there are parallels to some of the terminologies you may have heard and some of the terminologies that you're going to continue to hear. One is blockchain or the distributed ledger. In our story, a parallel to the blockchain is the email server that we use, right, to send these emails where the IOUs were transferred and where the email that I used to send to Joey, the 1.txt file. You can consider the email server a form of a blockchain. Is it exactly, are there differences? Yes, there are some differences, and we're going to talk about those differences, but the parallels the same in the sense that the email server keeps tracks of those exchanges. And our email address is similar to a public key or a wallet or an address on the blockchain, meaning that it represents an account holder. The email account password is similar to what's called a private key. And at some point in time in the future, we may do a session on cryptography and talk about public key and private key. But just to summarize, a public key is your portion of the key that you can use to encrypt something, and the private key, which only you should have, is used to decrypt. And you can also do vice versa. One can encrypt and the other can decrypt. However, the public key is derived from the private key, whereas the private key cannot be derived from the public key. Our unique essay algorithm is similar to the algorithm that Bitcoin uses, which is used for mining, which is called proof of work. It's a method for to allocate Bitcoins so that not one individual can hoard and grab all of the Bitcoins. It forces miners to do cryptographic computations so that when they do get those computations right, it's a puzzle. If they do solve that puzzle, they're awarded Bitcoins, and that introduces a brand new Bitcoin into the Bitcoin ecosystem. It basically is minted out of thin air. And the way that's used, the algorithm that's used to be able to allocate that is called proof of work. And it's very similar to this unique essay algorithm that we do. It's a way to spread out the ability to create coins, so you don't create an infinite number within a second or so. And the fact that we write these essays is similar to what's called mining. The fact that I'm CCing everyone makes the transaction public. And the fact that once I send an email, I can't really delete that email. Once it's sent, it's sitting on some server somewhere, and it makes it immutable, meaning that I can't go into somebody else's inbox and delete that email, right? And so that's called immutability, which is a big part of the blockchain. And if you've heard of smart contracts, the IOU is an example or a parallel to what a smart contract is. Of course, there's some differences, and we can get into that in the Q&A portion. Now, this is a screenshot from Satoshi Nakamoto's white paper, the Bitcoin white paper, where basically started it all. And you can see some of the approaches that we came up with in terms of CCing everybody on email are the approaches that he suggests in the white paper in order to form a cryptocurrency and a blockchain, right? So I've underlined in red the way to avoid and deal with double spend is to make transactions publicly announced, right? And I do recommend that you read the Bitcoin white paper. There's tons of information in there that are applicable to computer science students or data science students. So this shows that Satoshi's actually going through that process that we just went through, but he spent far longer on it than we have. We spent probably 10, 15, 20 minutes on it. He spent years on it trying to solve it, and using cryptography, we've kind of used other means that are kind of still breakable, but cryptography, he's using cryptography to solve a lot of the problems that we've just tried to solve. So we talked about blockchain, we talked about immutable public and transactions. The things that we haven't talked about is consensus algorithms and decentralized, and we step into that for a few minutes. Now, is email decentralized or centralized? We used email to store our transactions. When I was sending my TXT coin, send it over email. Is email centralized or decentralized, right? So email is actually today is centralized, meaning that if Google were to disappear, then our inboxes would disappear, right? If Google were to file for bankruptcy, our inboxes could be in trouble. And so it's not decentralized. Here, decentralized means that there is one single point of authority or a single point of failure that can control whether something exists or doesn't exist, right? And in our example, we did use email. The problem with email is that it's centralized. However, with blockchains, it's not centralized, it's decentralized. And the way that it works, if you recall from the days of Napster and Nutella, and if you're using things like torrent, we have this concept of nodes and peers where a bunch of computers are replicating each other and they're communicating with their peers. And this idea of doing peer-to-peer is how Bitcoin started. The opening line of the Bitcoin white paper is that Bitcoin is a peer-to-peer currency, right? And if you look at the number of Bitcoins across the globe, there are over probably right now 13,000 nodes. Each one of these nodes is replicating a full copy of every transaction that has occurred. So it's kind of like doing a CC. So when I do a CC in email, the problem with email is that it's centralized. However, when I'm doing transactions in Bitcoins, I'm recording transactions on the pair of nodes that do the transactions. And then those nodes excuse me, synchronize with every other node, every other of those 12,000 plus nodes, and all these other nodes are now collectively agreeing that these transactions are canonical and represent the true state of the transactions that have occurred up until the current moment. So this idea of the nodes being able to communicate and agree is called consensus. And there are several different algorithms that are used. This has become a very deep problem in distributed computing and how to get nodes to agree on a shared reality. And the way that Bitcoin worked to address this was called an algorithm called proof of work. If you're looking at other blockchains like Ethereum, there are other types of algorithms that are coming out, like proof of stake and Raft, and there are several other, there are probably easily a dozen of algorithms that are kind of emerging and becoming popular, and they solve the same problem, which is how do the nodes, now that they're all synchronizing, how do these all nodes stay up to date, and how do they avoid problems if one of these nodes is a bad actor, right? So a lot of these problems are solved using cryptography. So there are two main things that you need to know if you are looking to get into the blockchain space. In terms of cryptography, one is hashes, so cryptographic hashes, and the second is public and private key. Cryptographic hashes are used to identify a user on the blockchain. So on Ethereum and in Bitcoin, your public key is hashed twice using a hashing algorithm like SHA-256. And proof of work, which is the algorithm used to determine how to allocate Bitcoins, uses a computational puzzle that requires the solver to attempt to try millions of hashes to find a particular hash, and if they're able to find that particular hash, they're awarded Bitcoins. So modern cryptography allows us to do a lot of the things that we try to do with email, in terms of CCing and making sure that in fact it was me that sent that email and that it was the right party received it. And so modern cryptography is a major component of a blockchain. In terms of consensus algorithms attempt to solve a major problem in distributed computing, which is called the Byzantine generals problem, which is basically if you've got a bunch of nodes and nodes communicate with each other, there is no way for one node to know if another node is a bad actor. And so algorithms have emerged to try to solve that problem. And have solved that problem to some degree, but however, there's still work that's being done to try to improve that. So for example, with the Bitcoin, if you were able to control 51% of the nodes, and so let's say you control 6,000, 7,000 nodes, you will be able to control the value of Bitcoin. However, that would cost you potentially billions and trillions of dollars to be able just to do that, to be able to arrive at that control. And that's how algorithms work. They make it economically infeasible or impractical to be able to control a large portion of the network so that control can be decentralized and never really fall into the control of one or more or a few number of parties. Proof of stake is the emerging algorithm that's being used in Ethereum. Right now it's being used on Ethereum as a test on the test networks, and it eventually will move into production. The problem with proof of work is that it requires mining, and mining requires a significant amount of energy use. Proof of stake kind of does that away with that. It does not require mining. It requires different nodes to put up basically a stake. They basically say, hey, this transaction is true, and I put up this much money as stake, and if anybody disagrees with me and there's a majority that disagrees with me, then I'm willing to forfeit that amount of money. And that allows transactions to occur faster and without the consumption of energy. There's a bunch of other algorithms that are being used. It's called proof of authority. IBM's Hyperledger has one called proof of elapsed time. There's another one called Raft. There's a bunch of papers that are behind all of these algorithms, and some point in the future we maybe will do a webinar to dig deeper into these algorithms. These are fairly complex to get into but it's worth looking into. So I just to kind of wrap up, and then we'll get into the Q&A portion. So this is kind of an introduction to blockchain. Hopefully you've got a little bit a better appreciation for kind of the factors that are driving the challenges that drive the solution that Bitcoin has become. What are the things that we had to solve, or that Satoshi Nakamoto had to solve in order to create this idea of a Bitcoin and this idea of this a ledger where it could track and be immutable and track the movement of Bitcoin. And now that has kind of spawned off this entire new industry where the blockchain is kind of this unintended consequence of Bitcoin. So blockchain now has taken its own life in terms of its application in several different verticals, from government to supply chain to performance management, and definitely it's the initial use of cryptocurrencies, and so the applications for the blockchain have kind of expanded beyond the world of cryptocurrency, and the qualities that allow it to do so have been this based on cryptography and the fact that it's immutable and decentralized. So with that, I'm going to shift to the Q&A session. I've got a couple of questions. Will this webinar be shared after this? I think there will be a recording that Darian will have and would probably share after this. So I'll go over some of the questions. Why are several cryptocurrency emerging if all are based on the same idea? So so there are several cryptocurrencies that are emerging because each cryptocurrency may not be identical to the previous. So Ether, which is the cryptocurrency for Ethereum, it has different sets of underlying capabilities than the Bitcoin blockchain. So the Ethereum blockchain, which came after the Bitcoin blockchain, has the ability to do certain things like have code on the blockchain, which is called smart contracts. And a lot of these new coins are actually based off of Ether. They're denominated with Ether. So you might have a currency that was issued by an organization. That currency was issued as some ratio of Ether, even though that currency has its own name. And the reason they do that is that they want to have their own cryptocurrency ecosystem that may be applicable to certain use cases only. And that currency would have its own economics in terms of it going up or down in value. Okay, I'm getting a bunch of questions. Let me try to go one by one. And I'm going to try to get through most of these. I've heard of Bitcoin fraud, where Bitcoins are lost. How does that happen? So, so fraud, we can divide it into two categories, or a couple of different categories. So it's difficult to commit fraud on a blockchain in terms of detecting where Bitcoin went from what party to what party. That's kind of difficult to break and defeat. However, the fraud can come from some party who has been deceived or convinced into sending Bitcoins from one party to another, from themselves to another party. And so there is fraud there, and that's no different than fraud in any other industry, let's say mortgage, where somebody is maybe led to believe certain things, and then they move money, they move Bitcoin around. However, the blockchain, it does not prevent fraud. What it does do is help make it very clear what's the movement of the Bitcoin or Ether, such that it's possible to track possibly who is behind it. Now, a lot of these accounts are pseudo-anonymous, meaning that you don't know who holds these accounts, and that also contributes to the ease of how some people can commit fraud using Bitcoin. What's a Bitcoin Cash? A Bitcoin Cash is a fork of the Bitcoin blockchain, and a fork is basically this idea that you can split the blockchain and take it in a different direction if you've got a significant significant number of nodes that are willing to do so, and Bitcoin Cash is an example of a fork of the Bitcoin. Next question is, could you please explain what is double spending and infinite problem again? So double spending is this idea that I can take some currency and spend that same currency twice. You can't do that with dollars, because once I've handed you some money, I can't spend that again because I don't have it in my possession. But with digital currencies, that's a problem. If I were to use my TXT file as an example, the fact that I can use it as currency once, I can also then attach it to another email to somebody else and say, here, this is for you as well. And the infinite production problem is the fact that I can create an infinite number of any digital asset just by copying and pasting it, right? And I can easily create scripts that can create billions of the same thing over and over, and then say, hey, I've got billions of this stuff. If those problems exist, then any digital asset has a problem of having value that can really be sustainable. There's no way to sustain a value for a digital asset if those two problems exist for that digital asset. And Satoshi's brilliance is in the idea around him being able to find mechanisms to protect the value of a digital asset using cryptographic means, right? So the value of that digital asset is preserved because we can track that it's moved and that it can't be spent again, and we can control how many of those can be created. Is there a possibility that storing all transactions all over the world will create a data storage problem? Yes, there's been so right now maybe the Bitcoin blockchain is about 300 gigs, not a big deal for a lot of things, but over time that's going to be a problem. And there have been attempts to actually reduce the sizes of a block and increase the amount of space that is used for the overhead information or the metadata in a block, so that more transactions can fit in a block inside of a blockchain, so thereby reducing the amount of load that there is in terms of the blockchain size. And there's also what's called a Merkle tree, which is a data structure which allows you to check this massive tree structure of data just by comparing the parent nodes, hashes for the parent nodes, and you don't really need to then replicate the child nodes. You can just compare the hash of the parent nodes and say, hey, we've got a copy without actually having copies, and that's possible now, and that reduces the storage requirements. How is the value of any cryptocurrency decided, and by whom? If public decides it, then how is each person's acceptance taken simultaneously to process a transaction? Okay, so the value of any cryptocurrency is basically belief, right? That's the fundamental thing here, is that I believe the Bitcoin is worth $9,000, therefore I'm willing to buy it for $9,000. If I don't believe it's worth $9,000 and I believe it's worth $10, I'm not going to buy it today. Or if I believe it's actually worth $100,000 and it's at $9,000 today, then I'm going to buy it and try to hold on to it. And the second part of your question is, if the public decides, then how is each person's acceptance taken simultaneously to process a transaction? So basically a transaction, let's say you and I are doing a transaction through Bitcoin, my node and your node, we're interacting through a node. Our two nodes agree that this transaction has occurred. Then our two nodes are then attempt to replicate this transaction to other nodes, all other 12,000, 13,000 other nodes, and those other nodes are looking for proof that these transactions are true. And so then it comes down to cryptography, and then once it's proven that these transactions are true, all the other nodes accept that as transaction, and then every node has a copy. Blockchain has anything to do with cloud or big data? Yes, there are multiple ways that the two are tied in together. There's an enormous amount of work around big data analysis of blockchain, which is one of the things that I teach. And then there is blockchain itself, the idea that it can control how data is used, for example, privacy data, personal information, and how that's used. There are multiple intersections between data science and the cloud and blockchain. Next question is, can you explain a little bit of how transactions are stored, the chain of blocks concept? So the chain of blocks concept is basically you'll have a block, and that block contains a bunch of transactions, and the block after it will contain a pointer like a linked list. It'll contain a pointer to the previous block, but the previous block will have all of its content, or the header content will be hashed, right? And the next block, the subsequent block, will hash the previous hash to arrive at a new hash. So there's kind of a link of hashes, previous hashes. So if any previous block is modified, the header is modified, all subsequent hashes become invalid, right? And this is how the blocks are chained, right? And the transactions are stored within a block. A block is basically a bucketing system. It's just a way to aggregate transactions in some code. Let's see here. So I'm going to spend maybe another, let's say it's 5 minutes, and I will try to wrap this up. Let's see here. If anyone can create a currency token, then where is the value in that? Yes, that's a good question. So anybody can create a currency or token, and therefore a lot of tokens are created and they go down to zero. So the idea of creating tokens is one thing, then the idea of actually being able to create an ecosystem where that token is used is another idea. And there's a whole field of what's called tokenomics, which addresses this in terms of once I've issued a token, how do I make sure the token is traded and used and sustain some type of value. And typically, a token sustains value when it's being used, and there is a motivation to purchase it, and there's a motivation to use it. All right. What's an ICO? An ICO is an initial coin offering. It's basically when an organization or an entity decides to issue their own coins. It's typically these days denominated in Ether. So you can create a coin, name it what you like, and it will be some fraction of Ether, some ratio of Ether, and then people send you Ether, and you send them those coins. Can the hypothetical case of banks disappearing also happen to cryptocurrencies? Yes, so it can happen. So cryptocurrencies are decentralized, but one thing they are centralized on is the fact that they need electricity. So if for some reason the sun went away, and we're kind of all centralized around the sun, or these there was some problem with us, globally having access to electricity, then cryptocurrencies go away. And for that matter, even fiat currencies, one can argue, can go away, and we'd end up going back to maybe precious metals. What are the more valuable Bitcoins? Are they publicly available for investment purposes? Are they traded on some sort of commodities or marketplace? I don't want to say too much because it's investment. I don't want to misconstrue this as investment advice, but look into the Ethereum blockchain. A lot of the cryptocurrencies that are being released right now are coming on the Ethereum blockchain. There's a website called coinmarketcap.com that should have some information on some of the cryptocurrencies that are out there. Where do you store the private key of a wallet? Ideally, you want to store it somewhere where nobody has access to it. Most people that I know that have significant investments in cryptocurrencies, they print out their private key, they destroy any other representation of that private key, and they put it in a lockbox in a bank. And the other option is to use a USB key, where there's a company called Ledger that designs a particular kind of USB key called a nano ledger. It's available on Amazon for 99 bucks. I have a couple of them. You can store it on there. However, if you lose that USB key, then you lose access to your money. How much time will blockchain take to find out who did fraud? There's no time limit. In certain cases where the FBI have been involved, it took months. In some cases, it may take minutes or seconds. How did Bitcoin get hacked? Well, there are a lot more questions here than I have time for. Darren, should we wrap this up?
Sounds good.
Yeah, okay, guys. So we got a ton of questions. You have my email address here if you guys want to add me on LinkedIn. If you have some questions, please feel free to email me. If you like this material, think of, and if you're not a CUNY SPS student, I do recommend you take a look at the program. If you like more information about the program, please contact me, and I'll forward you to the right person. Again, if you have any questions, I'm sorry I couldn't answer all of them. There's probably another 30, 40 questions. Feel free to email me. Thank you very much.
Thank you.